Okay, afternoon, folks. In this session, we're going to be looking at mathematics from Form 1 class. Now, topics of interest are going to be fraction, percentages, square roots, cubes, cube roots, factors and multiples, rational numbers, prime numbers, number line, integers, natural versus whole numbers, even and odd. I hope you find this interesting. So, without further ado, we will dive into the first problem. Um, we are required here to convert a fraction 3 over 5 to a percentage. So if we are doing that conversion, we'll write our fraction, and because we want to turn it to a percentage, then here if we divide 5 by 5, it gives us 1. Into 100, that's 20. Then if we multiply 20 by 3, it gives us 60%. Right, we are interested in defining a rational number. So a rational number is a number, it's a number which can be expressed in the form P over Q, where both P and Q are integers, and Q should not be equal to 0 because we are not allowed to divide by 0. So P and Q, they are elements of integers. In other words, they can be positive or negative or numbers, whereby P is allowed to even take 0. Now we are required to circle all the prime numbers. So if we are circling, because they're given in order, the first prime is 7, then we have 11 and 13. So if I'm to write it them neatly below, I have 7, 11, and 13. Then we want to classify the following as natural or whole numbers. So natural numbers, they are all numbers which are bigger than 0, but they are positive. So 5 and 12. 5 and 12, we can say these are both, they are all numbers, and they are also natural because they are bigger than 0. So these are also whole and they are natural. But if I look at 0, 0 is simply a whole, but it's not natural. Now, moving ahead, we are required to identify of the following which are even, which are odd. So even numbers, they are divisible by 2 without leaving a remainder. So I can start by targeting even numbers to say with even, I have got multiples of 2, which are 18 and 44. Then the remaining should be definitely odd, which are 27 and 51. So moving forward, we are required to plot on the number line -3. So I'll just use a pointer to say there I can see -3, there I can see 0, I can see a 2 there, and then a 5. I think that's all that's required by this question. Then next we are in the set of vectors, multiples, and fractions. So now with vectors, the trick here is a vector is a number which can divide the given value without leaving a remainder. So obviously each number is divisible by 1. So the moment I divide 30 by 1, I get the last value, which is also a factor 30. Then because 30 is even, it's divisible by 2, giving us a 15, which is another factor. Then we can also move on to 3. 3, when we divide 30 by 3, it gives us 10. Then I also move to 5, which if we use it to divide 30, it will give us 6. So that's the list of factors that divide 30. Then the next we are required to find LCM of 6 and 10. So we use a method of prime factorization because 6 is even, is divisible by 2, giving us 3, which is prime, divisible by 1. So we can rewrite 6 as a product of its prime factors, which will be 2 and 3. Then we go on to 10. 10 is divisible by 2 because it's even, giving us a 5, which is prime, so it will be divisible by 5 alone. So if I write it below, I'm going to have 2 multiplied by 5. Now the rule, if we want LCM, we'll look at the common factors, then we take the lower power when we do a comparison. Now because these two, above and below, they are both of highest power 1, so 1 becomes the lowest power. Then I'll just write it once that these two, but we also have 3, which is a factor, and we also have 5. So if I multiply 2 by 3, it gives me 6 times 5, it gives me 30. Therefore, the LCM of those two is going to be 30. Now, the next problem I'm required to simplify a fraction. So now, if we are simplifying a fraction, would need HCF, or highest common factor. So I'm looking at 18 and 24. It looks like both are multiples of a bigger number 6. So it means 6 can divide both numerator and denominator without leaving a remainder. So if I divide 18 by 6, it gives me 3. Or if I divide 24 by 6, it gives me 4. Then I've simplified that fraction. Then moving to section C, I'm required to estimate to the nearest whole number the square root of 50. But what I know is, because 50 is closer to a perfect square, 49. So if I find square root of 49, it's going to give me exactly 7. But it will be somewhere around maybe 7 point something. Let me try and estimate 7.1. But they are saying to nearest whole number. So this will definitely give me a 7. So still moving, we are required to find the first 5 perfect squares. So if we want perfect squares, what we'll do is we'll square natural numbers, like 1, that's the smallest natural number. So if I square 1, it gives me a 1. If I square 2, it gives me a 4. If I square 3, it gives me 9. If I square 4, I get 16. I square 5, it gives me 25. So those happen to be the first 5 perfect squares. Now, on number 12, I'm required to find cube root. A cube root is a number where we multiply by itself thrice. I mean, that's a cube giving us the given value. So, is it a number? If I cube it, gives me 64. So that number definitely is a 4. Is it a number? If I multiply it by itself thrice, it gives me 216. Definitely the number is 6. I think basically that's all we have from this activity for Form 1s, where we are covering various aspects which involve properties of numbers, finding LCM, HCF, fractions and their conversions to either percentage or decimal. We also looked at the logic behind LCM and HCF, trying to simplify fractions and all that. And we ended up closing with squares and cubes. So that's all from this first series. Thank you.